Okay, so the faults. In which direction are they dipping? Are they steep or are they not steep? Well, they're probably very steep because there is quite a significant amount of topography and the faults tend to run across the topography without seeming to be massively affected by them. That is particularly true for this one, which cuts through valleys and hills and ridges and valley without being much affected. So we're talking about very steep faults, like probably with dip in excess of 60 degrees. This one is probably nearly vertical, but if you're thinking about, okay, in which direction is it actually dipping, if it's not exactly vertical, you can see that there is actually some inflection. You can see that when you get into the valleys here, like in the zones of depression, it tends to form an inflection in that direction. When you get into the ridge, it makes an inflection in that direction. That seems to suggest that it's dipping steeply towards the northwest. The other one, in the Bright Angel Canyon, it shows a bit more, it's more affected by topography, so probably very steep again, but you can see that you see little V's in the valleys in this area in particular. So we've got V's in the valleys that tend to have the tip in that direction towards the southeast. That seems to suggest, and you can see them here as well, so that fault is definitely dipping towards the southeast. But again, it's a very steep fault, so probably an angle of around 60 degrees. Feel free to try to use structural contour to get the deep angle here, but if you just draw something steeply dipping towards the southeast, I'd be very happy with that. Now, what you have to do is to build the section. So you've put your faults in, and you're going to build again from youngest to oldest. What is very important here is to realize that you may have to adjust your section because you have a topographic profile that looks like that. So we've got this staircase topography, and you can really see that, and that's probably the result of rocks. The rocks are bedded horizontally, so that's probably a result of the rocks having different resistance to erosion. So each of these cliffs will represent some rocks in particular. And you can see that if you start looking at the topography, when the contacts get too close, you will end up with these very dark gray lines. And you can see, for example, that the pink rock, the red wall limestone, typically covers this gray line. So the red wall limestone is going to make cliff. The dark green layer, you can see the contacts very nicely, so it's not going to make cliff. The light green is not going to make cliff neither. The Supai formation here is going to encompass 1, 2 cliff. The orange, the Hermit shale, is not going to make cliff. The Coconico sandstone is going to form cliffs. Again, you can see that. And the Toroweap formation is going to form cliff. The reason why I'm highlighting that is because you're going to try to report your contact. But you can see that if you're 1 millimeter off, you can end up with something completely unrealistic. So what I mean here is that when you draw your section, think geologically. So for example, if you have that contact, if the bottom of this bed is mapped here, so you put your contact here, and then the bottom of this bed is here and is a bit off, if it ends up here, don't draw that layer like that, because it's very clear that the layer is horizontal and that should actually represent the bottom of that cliff. So make sure that you have your contact representing, actually making sense. So make sure that the cliff are in the rocks that make cliff and the low angle topography in the rocks that make low angle topography. Similarly, you want to make sure that the thickness of the units on both hills that the cross-section cut is the same. So again, you may have to make some adjustment. You can't have here a layer that is like that and here the same layer being twice the thickness. So you may have to adjust a bit the trace to be able to preserve this thickness across the section. So these are the minor difficulties here. There is another difficulty, and it happens here, just in the middle of the Bright Angel Canyon. And here we're going to zoom in. Let's see if that works. Sorry. The best equipment I have here. Okay. So here we have, let me get something I can point with. The river is flowing at the very bottom of the canyon, and we've got that formation, which is the dots, which is the Hyakutake Shale. When we've got the dark green, which is the Bast Limestone. And then we've got something that looks blue. This is not blue, this is a printing problem here. So actually this is part of that light gray, light green here, which is the, let me check, I think PCBS. This is the Brahma schist here. So the Brahma schist, there's a little tongue of Brahma schist that is coming here and is going to appear at the very bottom of this line of section. It's appearing here, then we've got more limestone here, and the Brahma schist is here again on the other side of the fault. So draw your cross-section and think about that complication, how that's going to appear on your cross-section in this area. Okay, off you go.